You end up with 4. This example comes out of section 11.2, combinations. Okay, so in this question, we're given kind of a classic combinations question here, where we've got a bag contains 6 red, 4 green, and 2 blue marbles, and you're going to choose 3 marbles from this bag without replacing them. Without replacement just means you don't put a marble back after you take it out, which means that we are going to have numbers like 6 times 5 times 4 times 3, etc., which leads us to use permutations, combinations, or factorial. If you put the marbles back in, it changes the question completely. So basically just picture yourself reaching in and picking 3 at once. How many ways could you pick exactly 2 red marbles? Well, we have 6 red marbles altogether. We have to choose 2 of them. The order here doesn't matter. They haven't said you have to pick a red one and then a red one and then a blue one or something like that. As long as 2 of these 3 are red, we're fine. So 6 choose 2, but then we do need 1 other marble, and it needs to not be red. So from the other 6 marbles, the 4 green and 2 blue, we have to now choose 1. So we have 6 choose 2 times 6 choose 1 as our answer to that question. So 6 choose 2 gives me 15 ways of selecting the 2 red, and then 6 choose 1 gives me exactly 6 ways of picking any one of those other marbles, green or blue, and 15 times 6 equals 90. So there are 90 selections or 90 ways that we could do that. Now when they say how many ways in part B could you pick at most 2 red marbles, that means you could have 2 red ones, or you could have 1 red one, or you could have 0 red ones. Don't forget about 0 for some reason. People often do this question that way. And do the 2 and the 1 and forget that you could have 0 red marbles. You could pick all green and blue ones if you just reached into a bag. So we've already done the first calculation, which is exactly 2 red, which means 6 choose 2 for the 2 red, and then 6 choose 1 for the others. Now for 1 red, we'd have to say, well, we've got 6 choose 1 for the 1 red, and then we happen to have 6 green and blue ones, so we have to choose 2 of those. Turns out it doesn't matter which way you multiply that, you're going to get 15 times 6, or 6 times 15, 90, and 90. Now for 0 red means we have 6 choose 0 for the red ones, but we still do need to choose 3 marbles, so we have 6 choose 3 as our answer to that one. And it gives us 20 possibilities, 1 times 20. And so because of this word or, we're going to add 90 plus 90 plus 20, which gives us 200 selections that we could make that would have at most 2 red marbles. So 2 or 1 or 0 red. So this next example is similar, except that we're talking about cards being dealt from a standard deck of cards. Hopefully everybody's okay with what a standard deck of cards is. You have 4 suits in there. You got spades and clubs, which are black, and you have your hearts and your diamonds, which are red. You have 13 of each of these, giving you a total of 52 cards. And you have ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king of each of those suits. So if they ask us how many cards are decks, hands dealt from a deck of cards are going to contain 3 kings and 2 queens, we say, well, there's only 4 kings in the deck, we have to choose 3 of them. There's only 4 queens in the deck, we have to choose 2 of those. And so our answer is actually surprisingly not very big, considering how many cards you have. You end up with 4 times 6 equals 24. 24 hands only, which would have 3 kings and 2 queens. If you're playing a poker game, that's called a full house, and it's in fact a very strong full house, and there's a reason why it's so valuable, is that it's extremely rare. How many hands would contain all spades? If you count how many spades there are 13 of them, and we need to choose 5 of those cards. So if you do 13 choose 5, you actually get quite a bit more of these, 1,287 hands that would be all spades, which is called a flush, one of the kinds of flushes you can have. Now 4 aces is a little bit different. It's tempting to say, oh, 4 choose 4. There's only one way of getting 4 aces, but if you have 4 aces and you have a 5-card hand, you've got something else in that hand, and it can be anything. You've got 48 other cards that aren't aces, and you need to choose one of them. So what you end up with here is 1 times 48, which equals only 48 hands possible that would have 4 aces in them. Basically, you have the 4 aces and any one of your other cards. That hand is even more rare than the other ones, and therefore, in the game of poker at least, more valuable.